Yes. All right. Awesome. Thank you, David. Appreciate it. Oh, gosh. Thank you. I apologize. It's probably the only round of applause I'll get after the end of this. So by any means, if anyone wants to learn something, you are about 50 feet too far to the right. In any event, I'm going to get started because I find this interesting. So the fact that Dave said it's interesting, that's a good start for me. I'm still a consultant. I'm a former Big Four consultant, so I have to have slide decks with agendas in them because that way I know what I'm going to be doing and you can follow along. But long story short, I'm going to talk very, very briefly about myself. That's probably the most boring part about this presentation. I'm going to go through why this is important, aside because David Cowan said so. We'll look at some artifacts. We'll talk about some triage, and then hopefully there will be at least a question. And if the question is, can you please get off the stage now, then I'll be happily to field that one too. So that being said, I'm going to start off with, again, the boring content. Who am I? As David mentioned, my name is Matt Bromiley. I'm currently a senior consultant with Mandiant. I will be dead honest with you all. To share a slide deck template with Devin Kerr is probably one of the scariest things I've ever had to do in my life, because people walking out of his presentation yesterday still couldn't get their jaws off the floor. And then I'm like, all right, well, I'm going to try to live up to this slide deck. I've got years and years of experience with a focus on data breaches, incident response. I've done some network security monitoring, a little bit of threat intelligence, and kind of all that. I was a consultant. I've touched a lot of things. The client list I've worked for is small, dozen-person shops all the way up to a multinational 180,000 global Fortune 50. So I've kind of seen the gamut of all different sizes of networks. I'm a huge fan of open source forensic tools. If I can build it and script it, then I'm probably going to give it away for free if I can. And I also love to share. I love to teach. Is anyone in here staying for 4 or 508 for the rest of the course? Awesome. I'll be your TA, so we're going to have some fun learning together. And while I'm learning, I like to, help others improve, and that really helps me improve too. So there's a little bit of a selfish intent there, but it's good for all of us. And then also I tweet. I have a GitHub and I have a blog. As David mentioned, it's 505 Forensics. You can wrap whatever character you need at the front or the back to be able to track that. Again, if you have insomnia and you're looking for a cure, just read one of my posts. It's a fantastic way to fall asleep at night and not remember what you just read. So let's talk a little bit about why this matters. This is somewhat of more kind of a personal opinion of why this matters, but hopefully I can convince you of the same as well. So to start, NoSQL, to say it's new, it isn't necessarily new. It's not fair to say it's new because it has been around for a long time. But I'm going to say it's new in the fact that people are now starting to notice and are starting to use it and are starting to care. And one of the barometers that I have two barometers that I use for how popular something's getting. I use Gartner and I use universities. If a university somewhere has approved a study of something, that means someone's got some merit into it, unless it's a dissertation, in which case I put it to the side. And the other thing is, if Gartner's starting to pay attention, that means that a company that's built around investigating or surveying things has now said, okay, it's worth it for us to survey this, so they've invested that money. So that being said, we've got actually a screenshot of the latest Gartner but database Magic Quadrant up there, and Mongo's starting to make an impression. You've obviously got your favorites, right? Your Oracle, your SAP, your Microsoft, your IBM sitting up there in the top corner as the leaders. But look at Mongo sitting nice and high in that challenger section. It's only a matter of time before it either starts to cross the line or continues to rise in challenger and then crosses the line even easier and is higher up in the column there. So to say Mongo's not a threat from a market share point of view is, I think, becoming an understatement or a lie. So it's going to get important. And as David said, we're going to take a look at why Mongo becoming a market share in database systems is a horrible, horrible environment for the blue team. Awesome if you're a red teamer. And I actually gave a discussion on NoSQL injections at DerbyCon last year, and it was great from a red team point of view, because it's like, hey, here's how you pwn the crap out of everything, and the logs are sit. But we'll get into that. Couple other reasons. It's very, very, very easy to deploy. If anyone here is running Ubuntu, there's a simple command on MongoDB. It's 2 command line, and boom, you've got Mongo installed, ready to rock and roll. It's that simple. It's web app friendly, very, very, very easy to develop whatever your app may be. And I'm starting to channel a lot of my Silicon Valley watching here, where I just think of people just sitting around a room developing web apps for whatever ridiculous reason. They need somewhere to store all of this data. Boom, NoSQL. It's so much easier. I don't have to worry about a Microsoft SQL box. I don't have to buy all this memory and this massive hardware. I can just deploy Mongo on a DigitalOcean droplet or an Amazon AWS cloud, and boom, I've got a database up and running. There's APIs out the wazoo for all this kind of stuff. Every single language you've ever written in has got an API written for them. It's very, very, very simple to say, well, I'm a Python coder, now I need to interact with Mongo. Okay, boom, just use Mongoose. I write in Ruby, and now I need to interact with Elasticsearch. Okay, just download the Elasticsearch gem. It's all there sitting and waiting. So because it's all so easy, we've had a lot of players come out of this as well. Mongo is definitely one of the probably the more name-worthy ones, the biggest ones. Elastic, now Elastic, formerly Elasticsearch, is another very, very big player in this just because they just keep growing and growing in size. And their client base is enormous. Couchbase, Cassandra, and I've thrown Hadoop up here as well because Hadoop, while it is a massive distributed file system, there is also a database element to it as well that sits on top, and it's not necessarily SQL focused. Luckily, we're not going to dive too much into Hadoop in here, but Hadoop's another fascinating operating system. And the reason Hadoop really scares me from a NoSQL point of view, and I can share a quick anecdote. A couple months ago, I was asked to, I was scoping out an engagement for a very, very, very significant client that every single person here would know the name like the back of their hand. And the basic problem was we have a 6 petabyte Hadoop cluster. Oh, okay, what's in it? We have no idea. No, that's funny. No, seriously, what's in it? Do you have any type of schema, any documentation, any access controls, logins, usernames, anything? Oh, we have usernames and passwords, but everyone has admin read-write access. Okay, to 6 petabytes of highly, highly sensitive financial information. Yeah, can you help? Okay, all right. I don't know where in the development chain it came along that it was like, just throw everything into this giant bucket, and then we'll deal with it later. But it's a very, very legitimate problem that we're having. Who's using this? David mentioned there are some sensitive people using it. These aren't small mom and pop companies. These aren't startups. ADP, very, very sensitive information that I hope to God they've secured inside their MongoDB. The Weather Channel, if anyone's looking at stealing cloud forecasts. MetLife, very important, especially with the state of information security and healthcare/insurance in this country right now. The city of Chicago, because I know there's some Chicago people in here, so I'm not sure what they're storing in there, but hey, tax records can be interesting too. Elasticsearch has Netflix, Target, LinkedIn, OpenTable, GitHub. I know Mr. Roberts just talked next door, and I know they're using Elasticsearch pretty heavily, but luckily I'm assuming based on that they're a smart environment. Couchbase counts the Senate, BMW, Starbucks, and then Hadoop's got eBay, Expedia, Kayak, Samsung. So again, very, very, very big companies are saying we're going to use these stores, and it's going to only a point in time before your client or your next company says, okay, we're going to drop this in, and if security is not wrapped around these, your data is vulnerable from the get-go. It's not like, oh, at some point we did this upgrade and now this vulnerability came about. The default install is the definition of vulnerability. Because even with all this support, even with all these companies, the default still sucks. Kind of like we were talking about before, it's very, very easy to code. It's very, very easy to get data into. Data accessibility has become the primary reason you use these. The primary reason is not to make the most secure MongoDB in the world. It's to make the app that gets the user on their phone the information the fastest. So because of that, we've got apps that are built, data security takes a back seat, and it's not a primary consideration. There's actually a, I don't have a screenshot of it, but when we'll talk a little bit about the Mongo web interface. When you try to access the web interface, it comes back and it says, your RESTful API is not enabled. Also, please think about securing this port on your firewall. That's it. That's like the best mention of security that you'll get in a default install. And last but not least, and this is probably one of the most exciting parts of, again, one of my barometers of success, which is universities and a research they put into it. We're now seeing reports being published about internet-facing MongoDBs with little or no authentication. There's a couple guys who have been talking at DEF CON and different security cons for a while. Russell Bucciarini out of Nashville and also Ming Chao out of Tufts University. They've done some work on this kind of stuff, but probably the most recognizable report is 3 students from a university in Germany published a report in January of this year. They found nearly 40,000 MongoDBs openly available on the internet, no authentication, no passwords, no credentials. So they said, all right, let's do just a really quick sampling of the data that's inside and see how bad this problem is. Credit cards, social security, government identification numbers, names, addresses, phone numbers. If you can think about data you wouldn't want someone to have a hand on, they were able to find it amongst this population. And it got so great that the developers at Shodan said, you know what, let's write a Mongo filter. And let's write in for these ports that we know about. So now you can just go to Shodan and perform the same searches yourself. You don't need to do a massive port scan. So it's a little bit easier to find these, but from a forensic point of view, right, for the blue teamers in the crowd, as the information security industry starts to pay attention, and as the red teamers start to pay attention and start to build statistics about how vulnerable something is, that's when our ears should start perking up and we should say, okay, it's only a matter of time then before this side starts to overweight and then it all just topples over. I am fully expecting with the next few years to run into a breach, and the environment is all of our data is in Mongo, everyone here uses a Mac, we've all got personal file vault across the environment, and all of our servers sit in AWS. All of this awesome dead box forensics no longer matters because everything is in the cloud or everything is nowhere near where I am. So we've got to figure out a way to work with these differently. So that being said, we're going to focus on Mongo. We're going to take a look at some Mongo artifacts, or for what they are. I should have put quotes around artifacts just to make that point. And then we'll also talk about, from a forensic point of view, what can I do in the absence of artifacts? And hopefully that's something that carries across more than just MongoDB. So the first place I'd recommend if you find yourself looking at MongoDB is the config file. This is actually super useful for like proxy configurations, firewalls, anything that has a config file that's going to kind of dictate the who, what, why, where, when, and how. Mongo is going to be the first place to go. It's really simple if you've got a default install, and that's kind of the blanket preface for this is too. This is all just off of a default install. There are very secure Mongo instances out there. This is not a case study into those. But it's going to tell you, is logging enabled? If it is, where? What are we logging, and how is it logged? How are my logs split up? Is there a divider? Are they separated by day, by hour, by week, however it may be? Is there actually any security at all? By default, authentication is turned off, of course. And then access. What IP address is my Mongo bound to? What port am I using? Again, the default bind is localhost, and the default port is 27017. It's actually commented out, but you can change it if you want. And that may be one of the simplest changes to secure something like a default port scan. And then also is the web server enabled as well. And that's going to just either open up another door of horrible vulnerability access, or it's going to give you kind of the clearance to say, okay, there's at least one part that I know is not open. So that kind of helps out. So on top of kind of examining the log file, one of the other artifacts I look at is, okay, once I get to the config and I go to the logs, what's actually in the logs? What's actually stored there? What can I get out of them? So I started going through CRUD operations. And for anyone who hasn't done any DB research, CRUD is create, read, update, and delete. It's like the 4 basic database operations that you have in some way, shape, or form you're interacting with data. So I started out with creating just a simple record. I created a database called test data, and we inserted a post, and it was just like my first post. This is like the default Mongo test. And take a look. Kind of great log output. If we're in Mongo version 2x, if we're in Mongo 2x, we've actually got a log entry that talks about, okay, what was inserted, where was it inserted, and kind of some metadata around that. But look at version 3x. All I get is that a new data file was created from my database. So I was lucky because the use test data created the test data collection, the test data database. If that was already created, I wouldn't even have this entry. I would just have, okay, boom, data was put. Something happened with connection 1. Let's take a look at reading. And this is where I get to kind of ask for like a silent follow along. I don't know if anyone here has seen Spaceballs or any other kind of pop culture references I'm going to throw you in here. But let's take a look at reading. Let's do a simple find one. Let me hit a collection, and let me just find one record. This is like a random anything within there. Find one, so we got back my new blog post. And guess what? Nothing there. Ain't found a thing. There's nothing in the logs. At this point, the end of my log is still the creation statement. Let's look at updating. Let's take a post, which again let's make a variable called post, which is the blog post I just went through. We're going to do a random find, and we're going to drop in comments. We're going to create 2 comments. One of them, this is a comment, and this is another comment. And we're now going to take that post and update it, right? This is simple. It's just plain text. But I would love if this was a list of like ACH transfer instructions, and I was inserting a routing number and an account number. You would think that kind of important transfer would be logged, right? Nope. Nothing. Absolutely nothing. Our logs are still blank at the end. So we've read and updated and haven't done anything. So updating is a very, very interactive session, which is not logged at all. Deleting's got to be recorded, right? You're removing data from the environment, maybe possibly crucial operational data. So let's remove that post that we've been working with. Nope, whole lot of nothing. Nothing in the logs. So basic DB operations in Mongo, only one operation is recorded, and that's the create. And not only is it only recorded as a collection or a DB creation event, it doesn't give us any metadata about what was in there. version 2x, which it does. So I hate to say that a new version made the logging worse, but you know, one of the things that I like about these two screenshots here is you can tell very quickly about how these logs, they're written for developers. They're written for how fast did this take? What kind of benchmarks can I get out of these? They're not written for a security point of view whatsoever. They're not written for us investigators to look at these and say, okay, I need to figure out what the heck happened between this time frame. Instead, it's written, well, you guys can write really clean code. That's the best I got out of this log file. But that being said, we're investigators, we're detectives, so we don't stop when the logs have nothing. We keep looking for more. But to summarize, default logging sucks. That kind of highlights the importance of the config file. It's very, very easy now to get to a Mongo instance and load that config file, and you can almost predict what type of logging you're going to have. So our default port is 27017. That's going to help tie external logs into what we're seeing. We've now got a port we can filter on, or a port we can start to search for. Do we have authentication in Mongo? That's going to be another great artifact to look at as well, because that authentication may be pulling from another source. So that may be another log we can look at and see when someone may have logged in or when the password was issued at some point for an account. But again, because we're detectives, we know that if we can't hit the data source, then let's see if we can hit either what's around the data source or let's pull what we can out of the limited data we've got. There is. So while this is not a log optimization, you can go back to the config file, and there is ways to, you can get as verbose as, like, you can get millisecond by millisecond updates. I have yet to see it turned on, unfortunately. So there is a way. So that's kind of like why I like the config file, because the config file is going to say, oh, they've got extreme verbosity turned on, and it's sent out to syslog. And the config file is going to help tell you that. So it's either going to tell you where to go, or it's going to tell you what content you may have in the log file. Yeah, so something's stored. Something's there for you. And then there's other artifacts you can look at as well. So I don't want to diss the log files completely, because there actually is some useful information in there. The first one being user sessions. So upon connections, and I don't know if anyone saw this in the earlier logs, users are actually assigned an ID. This is me logging in from localhost. My localhost, I'm given ID 1. Anything I do from that point on is going to be assigned to a con1 flag. So there is a way to actually track user activity despite the limited information that you get. So this was actually the insert statement, the create statement. So while we know that was logged, you can see that I did something to the DB, and you can see that it's related to my IP, you can see it's related to the port I connected with, and it's related to my connection status. We just can't determine what exactly it was I did while I was there. That being said, it also is going to capture API and script interactions as well. So this is actually kind of a useful little point. If you're using an API to hit the DB again and again and again, it's going to get very, very noisy. I've seen connections get into the hundreds before, because it's sequential. So if we literally logged in and logged out of Mongo once a minute for 2 hours, we would have con 120 as our final connection. But there is a useful information point in there. Looking at next, the in-row data in Mongo can be very useful too, again, if it's done in the default. So this is a very sensitive remote. So by default, Mongo adds an _ID field to every data entry. You can specify this ID field if you want, for whatever kind of primary key tracking you may want. But if you don't specify one, Mongo is going to throw it in by default. Here's the best part about this artifact, and I'm calling it an artifact because it actually becomes that. This is a 12-byte structure with reversible information that can become very, very useful to an investigation. The first 4 bytes are a timestamp, so you can actually pull that out, and if the ID is default, you can see when the data was inserted. So if you've got malicious data with a default ID, I know when that was put in there. That starts to help me build a window around when my attacker may or may not have been interacting with the DB. We've also, the next 3 bytes are a machine identifier. If you've got, and it's very easy, and we'll see in a few slides when you line up kind of a successive of Mongo entries, it's very easy to pick out where the machine identifier doesn't fit in, where you've got the API putting everything in, and then boom, you've got 2 entries where it just doesn't fit anymore. We've got a 2-byte process ID, which is awesome, because now we can tie it back to a system process. And then we've got a 3-byte random counter. That doesn't provide much usage, except if we have a burst of activity within a period of time, and all of a sudden the counter is off, you could use that as proof that maybe something's been deleted. Maybe something is not there that should be there because we're missing that entry. And this will all make sense when in a couple slides. I've got a better screenshot of how to line that up. We can also pull Mongo artifacts out of memory. We can use system memory dumps to actually carve sessions, to carve in memory data. As you can imagine, some of these tools are written with kind of memory operations or memory optimization in mind, but not necessarily dumping the Mongo process and then pulling everything we can out of there. Instead, we can use what we know about Mongo and use that to craft our searches. So we know every entry is going to have an _ID field. Whether it's custom or not, that's an indicator for us. We know that Mongo is stored in JSON, so we can do a JSON search. And we also know that CRUD commands have certain structures. So it's going to be db.collection.insert.find1.remove, whatever it may be. So knowing what we know, we can dump strings, and we can look for what we expect to be there. So this is the same machine. And this was a script that I wrote that inserted 500 entries, and it did just numbers sequentially, and it just dropped them in. I never viewed this in the output. It was just data that was thrown into Mongo. I wrote the script, waited 10 minutes, did some activity on the machine, and then dumped memory, and then ran strings through it. And I just did a search for the ID field. Well, luckily, I was able to pull back all of the different, or not all, but I was able to pull back a large amount of the strings that I had inserted in there without any log entry or without any console viewing whatsoever. And if you take a look, you can see the timestamps in the red box. The machine ID and process ID are what I really like to hone in on if I'm looking at sequential data. It'd be very easy to pick an anomaly out of that list. When you look at it in this context, it's very easy to see, hold on, one of these doesn't line up, one of these doesn't make sense. So finding suspect data actually becomes a task that's actually worth doing, and you can be sometimes quite fruitful. Taking a look at some of the other structures and contexts that we know, I did a test. I knew that there was a test data collection in there, so I did a search for, okay, show me everything which is db.testdata, which is going to be the initial part of my CRUD commands. Well, I actually found the script that I wrote to insert 500 rows or 500 documents into my Mongo store, and then I was able to say, okay, if I know that test data is my collection, let's just back out and let's just take a look for test data and see what was actually there. And now I'm actually able to pull out log entries as well. So memory can be your best friend if you're trying to look for, and this is no secret to any forensicator, how useful memory can be when your artifacts are limited or next to none in these type of environments, especially with NoSQL data stores. So that being said, it's nice to talk about how bad everything is, but once we know what's actually there, let's talk a little bit about NoSQL triaging and how if we do run into an environment where we have a NoSQL data store and we need to pull some type of data from it, let's take a look and see what we can use to pull that and then how we can pull it in. I've kind of lined up a tool release with this as well, so I hope that helps out. If anyone here runs into Mongo, I'd love to hear that story. But let's take a look and think about kind of an idea for NoSQL triage first before we actually get into triage. Let's say we encounter a DB. What do we want to know? Well, you're going to want to know metadata around that DB about what's in there. Information, the collections. I know JSON or these types of data stores are technically schema lists, but there is some form of a schema there. Users, any recent operations, cluster, and then also we're going to want to take a look at our source data, the data that we've kind of talked about before, our config file. Do we have any other logs that tie in? Is there any external information we can wrap in? And then we can actually use Mongo itself to pull back great information as well. And then I talked about this briefly earlier, but when we look at kind of the built-in web tools, Mongo actually has a built-in web interface. It's disabled by default, thankfully. Someone actually thought to turn something off. That's where the config file can help out. But it's a great source of information if it is turned on. And actually, the report published by the German university talks about how many of these have it enabled, and it's a number, in the tens of thousands. This is actually the kind of the top of the screenshot from the Mongo web interface. This is not recorded in the logs, me hitting this. And it's a great little information store to start to look at kind of the overview of my system. MongoDB Tumblr is actually the name of the VM that I was running in. So you get system information, you get IPs, uptime, OpenSSL, a lot of metadata, which is great for an investigation and great to kind of keep on file. Now, there's also built-in tools that Mongo can help us search through as well. Again, these are all built for developers in mind, so they're built for metrics reporting, timing, how fast are you doing concept A, B, or C. From a forensic point of view, I like this data because I need to report on something, and that something that I'm reporting on is great. I don't care so much that it took you 19 milliseconds to insert data into collection 1. What I care more about is collection 1. So MongoStat is one that, it's a quick overview of the running instance, but I'll be honest with you, I look at that screen, I don't see much from a forensic point of view. This doesn't do much for me. But it's there, if for whatever reason you needed to say, okay, how big is my data store, how it's mapped out, that might go through. But what's interesting is that it actually tracks insert, query, update, and delete commands, aka our CRUD operations. In a much, much, much larger environment, this is going to track the operations that you see going on. So if you are in a large production environment, this is going to give you an idea of how active is this server on a per second, per minute, whatever basis it may be. What type of a behemoth am I actually dealing with? But again, from a forensic point of view, that's just a snapshot of dev. More importantly is Mongo top. Now again, developers in mind, it's built for how fast am I doing read and write operations. But we're forensicators. I don't care about read and write operations. What I care about is that I just ran a command that has no log entries that gave me all of the collections that were inside of this particular DB. So that's an awesome forensic source right there where I don't have to hit Mongo and I don't have to traipse all over my evidence, and I can get a list of every collection. And it's broken down into db.collection and then whatever may be inside. So admin system roles is the admin DB, system collection, and then roles are going to be the various documents inside. Admin system version, so on and so forth. So from here, we've got a snapshot of what's inside. And then there's also, and this is my favorite one, Mongo sniff. And I don't know who came up with the idea of putting this in there, but someone had security in mind. Mongo sniff is, okay, so quick caveat, it's not included by default with Mongo. You have to build it from the source. But Mongo sniff is essentially TCP dump for Mongo. That is literally the website definition of what Mongo sniff is. Again, requires special build instructions. However, if you're in an environment and you have Mongo sniff, I would definitely use that because it's going to hit Mongo immediately and directly instead of you having to get TCP dump and get it operating and working. And then take a look at this. Well, we can also use Wireshark as well to parse that traffic. So Mongo sniff may be able to give you that PCAP output. But take a look. Wireshark actually has Mongo decoders built in. So we're able to tell hey, this is Mongo traffic. So another source of data is going to be our network dumps. Memory and network together can give you a very, very good overview of what you're seeing happening to, in, or beyond your MongoDB. And then I took the liberty of actually matching these two up, our PCAP with our MongoDB log. And our ports, our connections, and everything line up. So it's a nice little kind of tie-out to see how everything is kind of working together. I unfortunately don't have the TCP stream screenshot in here. However, you can actually rip out the full commands that were sent through. So again, if the log isn't showing you what you want to see, if you got a PCAP, you've got some sort of network information you can look at, you can pull out your statements out of here. So again, an excellent resource, great place to go to for these. And then last but not least, we can go to Mongo itself. Mongo is a JavaScript-based DB store, so it's got great commands inside that we can use. Caveat, don't need to say this out loud, this may start to trample what you're going over. This is going to be operations that the database is performing. There's going to be a connection established to perform these. You may have log entries that show you in there that may overwrite other things if you hit a rollover period. But sometimes you need the information and there's a risk that you can accept. So like db.serverStatus, for example, is a quick Mongo command, a quick JavaScript command in Mongo, and it basically just gives you a massive JSON dump of everything going on. This is the top of the screenshot. It's your host, it's your version, it's the process. You keep going further down, you find out the size of the cluster, how many nodes do I have, what are my data stores, what are my collections. It's a massive collection of great information, and it's a really quick kind of one-off DB information. But even better, we can actually issue JavaScript commands through the command line. So I don't need to get into the Mongo shell to issue these. You can do a Mongo --eval and pass it legit JavaScript, and Mongo will parse that JavaScript and give you output in the command line. Now, if I'm a red teamer, I'm extremely excited when I can see that something can parse JavaScript from the command line. I love this. But from, again, keeping our blue hats on, we can use this to our advantage. This now gives us the ability to script things. It gives us the ability to pull things remotely and to actually do a little more than kind of fumbling around triage. So I don't know if there's any Tool Time watchers or any home improvement watchers, but I haven't seen it show in a really long time and felt Tim Allen deserved a little bit of respect in there. But what I wanted to do now is just take a moment. I know that the demo gods have not been the nicest to this summit, so all I've got are screenshots. But literally the second I can get back to my keyboard, I'm going to take this repo and make it public. So if anyone has any interest in this kind of stuff, you can feel free to look through the tools. But what I wrote is a really quick MongoDB triage script. I'm a loser, so it's version 0.1 right now. I'll probably hit 1.0 in like 5 years when I finally determined it's worth it. But for now, I'll just keep subversioning until I can. But what this is going to do is it's going to take a lot of those different commands, and it's going to make it a lot easier for you to run. You don't have to remember them, and if you do run into a MongoDB script, it's going to pull back some information for you. It's going to pull back your server status, which is that command that we saw. It's going to pull back your databases. It's going to pull back your collection information, and it's going to pull back the usernames and roles that are within the DB. So from a triage point of view, it's one script. It hits everything from the outside of the Mongo shell, so very, very, very little log trampling. And it pulls back everything. And then just to kind of walk through, it can work locally or it can work remotely. So you can feed it a port or an IP if you want. And you can start from a test box and hit Mongo afar, or you can go locally and hit Mongo close. I'll be honest with you, right now, it's just a very, very simple bash script. There is a plan to make it kind of more robust and use some of those Ruby and Python APIs, but if you remember me saying earlier, APIs hit your logs, and they are extremely, extremely noisy. Every single one of these outputs is going to be at least 5 to 6 lines added to the log. So 4 files out. We're very quickly getting at 30 lines in my log that weren't there before. So in an attempt not to pollute my evidence so far, we can start with simple Mongo. But that being said, I'd expect development in the future to include more API interaction because it is more robust. And then as a triage, as an examiner, that's kind of a risk we have to accept. And then here's an example of a couple of the outputs. We've talked about server status. Server status, one thing I didn't mention is it actually gives you network bytes in and bytes out. That's tracked by default, so that's another kind of resource you can look at. And hey, my MongoDB is only a gig, and I've had 10 gigs out over the past hour. There's something not right here, and I don't have a busy server. And then it also pulls back databases information. So databases is going to be what databases do you have, what size are they empty, what's the total size of my DB. So you can start to match up all these stats and wrap this metadata around what a MongoDB, what your data store is of interest, and then all of your other artifacts either may or may not make sense as you're starting to look at that environment. So with that, again, as soon as I get to my keyboard, I'll make it public. If anyone's interested, it's going to be at my GitHub page at 505forensics or github.com/505forensics. If it's any interest to you, I'd love some feedback. Currently, there's only a MongoDB bash script, but probably within the next 3 days, I've got Elasticsearch, CouchDB, Hadoop, and Couchbase quickly on the way. I just had to deal with the remote parts of those because it's a few more commands. And then more importantly, and you know, if it's a public story or if it's a private story, if anyone's encountered NoSQL in your environments, I'd love to hear about it. The shortest anecdote I have is at work the other day, I actually had someone hit me up and say, hey, I see you're talking about this. I'm trying to break in and figure out how to use Mongo as an entry vector. And you can actually be sitting in a Mongo shell and with a couple commands read out etc password if you need to, and then subsequently etc shadow. So it's all there. There's a lot of capabilities inside, and luckily we didn't get to talk about much of those now. But there's a lot of opportunities to do evil here. But I like to look at it from a positive point of view. There's a lot of opportunities to really secure your data with a clean, easy to use, easy to install, free and open source database store. So hopefully you concern more with the latter and not with the former. But that being said, thank you all for kind of watching and attending today. Again, like I said, if you wanted to learn something, you should have been next door. But hopefully this was insightful to at least one person. With that, if there's any questions, I'd love to field them now. And again, any anecdotes I'd love as well. Yeah. There is now. I really like that. So for me, and I think David made a good point, this is a very uncharted space. I'm like in the map of a video game where it's just cloudy pixels, and because no one's been there yet, right? So how people can benefit from NoSQL research in the future, I'm all ears. I'd love to hear about it, because I think your point earlier about can you even, is this all for naught? Can you even turn logging on? That's an important discussion to have with people who are administering these DBs of, yes, you can, here's how you should do it. So yes, now there is. Yeah. Agreed. Yeah, there's no point in us pointing out vulnerability all the time. Right? Don't answer a problem with another problem, right? Exactly. So no, now there is, but that's definitely an avenue I will go down. So thank you, appreciate that. Yeah, I don't know how I am, if I'm way short on time or. Oh, okay. Well, if there's any other questions or anything, if not, I hope everyone can have some free time before lunch. Quick plug: go watch the forensic lunch when that comes on. That'll be extremely important.
So, as you were saying, forensic lunch is at 11:10 in the room next door. No lunch is served. there will actually be a lunch and learn where real food will be served. 2 lunch and learn. So take the time that Matt has given you now to sign up before the other track does, if you would like a free lunch today.
You're welcome. Thanks. Appreciate it.